Welcome to Veera's classroom. In the series of signal flow graph problems, this is the third problem. This problem is somewhat different with the other problems because the diagram itself is somewhat varying, and finding the individual loop forward path gain it will be somewhat difficult. So we'll start with the problem. The step 1 of the signal flow graph is to find the forward path. That is, a path should start from node 1, that is R, and it should end with C. Fortunately, in this diagram we have only one forward path. It starts from the x1, goes to x2, x4, and moves to x7 and ends at x8. So we have only one forward path, that is a straight line. We do not have any forward path at all. Okay, this is the only forward path available. So the forward path equation, forward path gain P1 equal to G1, G2, G3, G4. That is simple. We will move to the second step, that is individual loop gain. What does it mean by individual loop gain? It should start from one node and it should end at the same node. So we have to find the individual loop. We have 2 to 3 individual loop gains here. We'll see one by one. We'll start with this loop. In this loop, x3 and x5, it goes through G7 and comes back to x3 through G12. This is individual loop gain 1. The second one denotes this triangle. This triangle, it starts from x3, goes to x6 and goes to x5 and comes back to x3 again. This is individual loop gain 2. And when you are going to see this a balloon shape at x6, that is again an individual loop gain. It starts from x6 and comes back to x6 again. This is individual loop gain 3. The bottom, we have an individual loop gain that starts from x3, goes to x4 and comes back to x3 again. This is individual loop gain 4. And we have one more individual loop that starts from x3, goes to x2, comes to x4 and comes to x3 again. This is individual loop gain 5. And we have one more individual loop gain that starts from x3, goes to x4 and moves to x7, x6 and comes back to x3. This is individual loop gain 6. So according to the thing, we have nearly 6 individual loop. No, we have 7 individual loop. We will see the final one. It starts from x3, goes to x2, x4, x7, x6 and x3. So we have 7 individual loops. So we have listed on all those individual loops. It's just multiplying all those terms, all those loop gains, signals multiplication, and we will find the individual loop gain. So P11 is G13, P12 is G10 into G12, G11, P13 is G7 into G12, P14 is G6, G7, G8, P15 is G2, G9, G10, P16 is G2, G9, G3, G5, G6, P17 is G3, G5, G6, G11. Okay, so how they are naming this individual loop gain here is, how I have named is, the P11, the subscript 1 is represents the individual loop gain, and the second term, that is 1, 2, 3, represents the number of individual loop. So it is P11 means individual loop gain, that is first loop. P12 second loop gain. P13 individual loop second. P14 is fourth loop. Such a way I have created this numbering. It is P11 to P17. What is the third step? Third step is to find two non-touching loops. So here's the major struggle, because we have nearly 7 individual loops. We have to find 2 non-touching loops. So we'll move to the diagram and we'll check it out. We have one loop here, the x6, the smallest loop. Mostly this x6 will form a pair with most of the individual loops again. So this individual loop will fall pair with this one, this pair, and the pair again here. So we have nearly 3 individual loops that doesn't have any common node with this x's. So this forms 1, 2 first pair, second pair, and third pair. So we'll see the forward path gain. We have 3 combinations. So it is P21 is P11 and P12, P22 is P11 and P13, and P23 is P11 and P15. So we'll multiply the terms. So the P21 is G10, G11, G13, P22 is G7, G12, G13, P23 is G2, G9, G10, G13. So we have found a 2 non-touching loop. There are no 3 non-touching loops. So we move on to the calculation for del and del k. Del is equal to 1 minus sum of individual loops plus sum of gain product of 2 non-touching loops. We will substitute all those values. So the answer for del is, it is 1 minus G13 plus G10 G11 plus G12 G7 plus G6 G7 G8 plus G9 G2 G10 plus G9 G2 G3 G5 G6 plus G3 G5 G6 G11 plus G13 G10 G11 plus G13 G12 G7 plus G13 G9 G2 G10. So this is the value of del. So we'll move on to del 1 and del 2. Here we have only one forward path. So that forward path means we have the value of k is equal to 1. So we'll have only del 1. So del 1 we have to find what are the individual loops that doesn't be the part of this forward path. So this is the forward path, and we have to find what are the individual loop that doesn't have any common node with this forward path. So this is one individual loop, and this is another, and this triangle is the third one. So this is the forward path, and we have 3 individual loops that doesn't have a common node with this. So this is first one, this is the second one, and this triangle forms the third one. So we have to add all those things. So we'll see that the value of del 1 is equal to 1 minus P11 plus P13 plus P14. The value of del 1 is 1 minus G13 minus G12 G7 minus G6 G7 G8. So the value of transfer function, it is 1 by del summation pk del k. The value of k is 1, so the formula becomes simpler. It is 1 by del into P1 del 1, so it's P1 del 1 by del. So we'll substitute the value of P1 del 1. The value of P1 is G1 G2 G3 G4. Del 1 is 1 minus G13 plus minus G12 G7 minus G6 G7 G8 divided by 1 minus G13 minus G10 G11 minus G12 G7 minus G6 G7 G8 minus G9 G2 G10 minus G9 G2 G3 G5 G6 minus G3 G5 G6 G11 plus G13 G10 G11 plus G13 G12 G7 plus G13 G9 G2 G10. So this is the value of this transfer function. We have solved the problem. If you like this video, click the like button and share it with your friends. Subscribe the channel for constant updates. Click the bell icon. Thank you.